In the last sessions, we learned that we can have static variables that are shared with the different objects, but we can also even have some methods on the class level itself. So far, we learned about what we call the instance methods. These are the methods that we define and typically have the self object in the first argument, and we can use it to access and change the attributes. Static methods, on the other side, are defined at the class level, not on the object level. They don't get self-object as a first parameter here. They cannot change object attributes, and also you shouldn't use them to access the static variables, as we will learn. You can think of static methods as simple as you have some very generic functions that actually should be put outside the class, but you still think they are relevant to the class, so maybe it's a good idea to put them inside it, although they don't have any access to the static variables or to the objects itself. Let's give some examples. If you have some function that check if a list has to filter the duplicates for you in a list, as you see, it all what you need only the list and just do some changes inside it. Function like is even, checking if a number is even or not. It has nothing to do with the static variables or the object attributes. Get positions neighbor. They are all actually general functions, but it might be sometimes they are very relevant to the class, so you would like to put them inside the class to not scatter the global scope with more names. Here is how you implement them. I'm here having a class that takes a name and it's calling a function. We call it process. The function process is decorated with @static method. Then this means that this method is a static. It doesn't take self as a first parameter. No one can pass a self here, and also it doesn't interact with the class or the object itself. Now here the target of the function is to take a name, split it to be first name and the remaining as last name. For example, if you pass the name like 1, 2, 3, 4 keywords, the first would be Mustafa and all of the remaining would be list of Saad, Ibrahim, Muhammad. And then you join all of them with a space, so it's now the last here. So it converted the name to lower, split it in this nice name, first and last. As you see, this function has nothing to do with the class itself, neither the attributes nor even the static variable of the class. We call this a static method, and you can call it with the the class level here, for example. And this is a recommended way. When you call it this way, we have a good sense that we are accessing a method on the class level. So again, this method doesn't take self, doesn't do anything with the static variables, doesn't do anything with the object attributes, just a function that can actually be put outside the class, but you felt it's good to put it inside the class as it's more relevant. On the other side, there is what we call the class method. Also, it is defined on the class level, not the object level. And also they don't get the self object. However, they get an instance of the class type itself, and this means that they may modify the class attributes, the static variables. So what are the usage of that? One of the best usage is what we call a factory method. Factory method is something coming from design patterns, where you would like a function to build the objects for you. During the course of projects, you should get a good sense of what might be a factory method. It's just something that creates for you objects. Also remember that it is shared between the different objects to manipulate maybe class attributes or so. Let's see how to do that. Here is the function we defined in the last time, the static method. We now define here a class method, and we pass class here, which is the word the person here. So the person here would be passed as a class. This isn't self object, it is the class itself. And here I code the function named the process, for example, and passed the full name for it. And observe here, I created an object, and see how Python is very flexible. Like this function automatically will be passed the class as a person here as a parameter. And then when you return the class first and last, the class is actually the person. So it's like a person first and last. So, we did changes definitely between this code and the last code. The last code has a first name and has only the name here, for example, but here I'm designing another thing that has first and last directly, so we have them here. And we are providing we are trying to provide some tools to convert it from the old style to the new style. That's why here I provided the function get person from full name that take full name, make the split, create an object using the full name. So the core lesson here is the static method just take normal parameters, or it has normal parameters and has nothing to do with the self or with the class itself. This is the convenient for it. It's like a very generic function. The class method taking the class object as a parameter. This function we call it a factory method because it is creating an object from the type of the person. It can create objects, it can access static variables. And this is what we call the instance variable. It takes the self. So instance method takes self. Class method take an object from the took the class here, and static method take nothing. A few remarkable things about the class methods. The method depends on the best argument class for the class itself. One good thing here is if the class name is changed for any reason, the method doesn't change. So going back to here, let's say that you change it at any point of time the word person to big person, for example. This method will not be changed because it depends on the class that will be passed automatically. Observe here when we call person.getPerson, we only pass the full name. The class will be passed automatically. So this is one good thing about it. And this is an application of the dry principle, the don't repeat yourself. Later we will learn about the inheritance, and we will know that when the implemented method at the parent is extended, the visible child will see also the function too. I know that you will not understand that at the moment, but later there will be like a person class and child class, and this method will be working very well for both the parent and the child. But this method will not work well. That's why the advice is this static method shouldn't try to deal with even the class object or the class itself. It shouldn't. If you would like to deal with the class itself, use the class method. If you don't need, use the static method. And also observe that we are sharing intentions with others. When I see that you are defining a static method function, I know that this is a very generic function that can be written outside the class, but you put here for convention. And when you define a class method, I know that this is function that is receiving a class, and probably it might create an object or manipulate something in the static variables, and so on. So even these things share in a very good way the intention of the users. For educational purposes, I would like just to know that we can do things without the decorator things. For example, you can here define the myProcess function in the same way, but we didn't put the static method here. And then you can come here and say that person.process, you are creating a function here inside the person class, and say that this function is of type static method. The static method is a function that take a function and convert it to a static method. And also observe here on the fly we are adding a function to this class. This class has person and myPerson, and we are now introducing person as a static method. I use a different name to just tell you that we can even do that in a practical way. You will name this function even also process. The purpose of that is just to know that even we can create things without the properties, without the decorators, but you shouldn't do it this way. This is like a less Pythonic way. That's all.